Thank you very much, Professor Al-Mazrui. Good morning. It's a great pleasure and a great honor for me to have this opportunity as part of my first visit to the kingdom to present to you a brief introduction to the World Climate Research Program. And the main purpose of my visit is to invite the scientists from the kingdom to become active in the World Climate Research Program. To introduce the program, to describe what type of research the program is coordinating across the globe. I will divide my presentations into three parts. First, introduce the program, when it was established, what is its purpose, and you will see that there is a network of several thousand scientists from around the world participating in the program. And they are all participating as volunteers because they're interested in cooperating, because some of the scientific problems are so difficult that no one nation, let alone an organization, cannot solve them, therefore it requires cooperation internationally. I'll give some examples of the contributions that the WCRP is making to the global science. And then I'll end with some challenges that the research of climate and environment is facing for the coming decades. What is remarkable, I did not coordinate my presentation with Dr. Al-Mazroui's presentation. You will see that tremendous similarities between what you are trying to establish here as the Center of Excellence at King Abdulaziz University with what is the rest of the world is doing. So you have a tremendous opportunity to really contribute to the global science in the coming decades. And I do hope that I can play a small role in connecting the Saudi scientists to this global network of scientists who are pursuing this kind of research. This is the outline of my presentation. The World Climate Research Program was established more than 30 years ago at the conclusion of the first World Climate Conference, where the nations of the world, about 150 nations at that time, decided that the subject of climate change will be with us, with our generations and future generations, and we need to put in place a program to understand the Earth's climate system, how it functions, how it works. Not to specifically, as Dr. Al-Mazrui said, that to point the finger at anybody, but try to understand how the natural system of the Earth's climate behaves on annual timescales, on decadal timescales, or even longer timescales. Of course, at the time there was concern that, as the population grows and we have to basically raise food and sustain our generation, the next, we will undoubtedly will be influencing the climate system. And then the second objective was that, can we say something about how much of the change that we will see or we will experience is due to the natural variability of the climate itself, and how much of it could potentially be due to the role of humans. About 20 years later, the scientists who were involved in the program thought that looking at the physical climate itself is too limiting. We really must look at the entire Earth system, the biology, the chemistry, the life, and therefore they coined the phrase of the Earth system science. The other objective that they defined for the program is that if we generate this scientific knowledge, we understand how the system works, but if we do not make that knowledge available to those who could use it for decision making, for development, for managing natural resources, we have missed a great opportunity. So they said we must focus on understanding and developing the knowledge, but we have equal obligation to make that knowledge available to the society. If we do not do that, we have failed our mission. So that is the purpose of the program. So on one hand, very similar to what the Center of Excellence is trying to do here. We focus on scientific understanding of the problem. On the other hand, we have to somehow translate the scientific knowledge in ways that are useful to decision makers. For example, Dr. Al-Mazrui said, can we say something about the climate over the next decade or 2 decades from now? Can we say something about the climate of the next season? Is it going to be more wet or dry? We have more experiencing more drought or less drought. That translation of scientific understanding to those practical decision-making tools is not straightforward. It's challenging, but it's something that we must do, and the program is doing that. Of course, we need the tools to do the research to create the understanding. The first and most critical component is observations. Without observations, we cannot say anything about the system. We must observe the system to see how it behaves. But unfortunately, observations can tell us something about the past and the present. They cannot tell us anything about the future. That's where we use the computer models. So the combination of observations and models are absolutely essential for us to say something, to learn about how the system works, and to say something about how it may behave into the future. If we have all the observations in the world, we have all the technologies and the capabilities and all the resources in the world, but if we do not have the human power, the intellectual leadership to interpret, to use this, we cannot really make progress. So that is why the universities and educational institutions are absolutely essential in this endeavor. Without the next generation of scientists, the leaders, we cannot complete this task. So those are the, very simply stated, the objectives and the missions of the program. And I hope you get to see that this is why I am here, because this is one of the centers of excellence in the region that does have the capabilities, the intellectual leadership to contribute towards understanding of the Earth's climate system, specifically the role of the Arabian Peninsula and this part of the world in the climate system. The way that we have organized the research activities is such a complex system. We have divided it into the components. One aspect is understanding the role of oceans. 2/3 of the Earth's planet is covered by the oceans. Oceans are the memory of the climate system because they store the heat, the excess heat that is in the atmosphere, and release it gradually. The circulation of the ocean from the tropical regions to the poles create the weather that we experience. So without understanding the oceans, we cannot predict or understand the climate of the Earth system. Likewise, it is important, of course, for us to understand the role of the cryosphere, the frozen part of the planet, the polar regions, the sea ice over the seas, as well as the glaciers and ice caps on land. So the second project of the World Climate Research Program focuses on understanding the role of the frozen water on Earth. The third project focuses on understanding the chemistry and composition of the atmosphere and its impact on the climate system. And the fourth, by far the largest component of the program, it is focused on understanding the role of water and energy. This is where the understanding of that knowledge is critical to subject of drought, floods, monsoonal systems. So scientifically, we have organized the research activities into those 4 major projects. These projects are all over the world. For example, the oceanography project is being hosted by the United Kingdom in Southampton. The part of the project, the program that focuses on the frozen Earth is hosted by the government of Norway. The part of the program that focuses on understanding the chemistry of the atmosphere and its impact on climate is hosted by Canada, soon to be hosted by Switzerland. and the water and energy program is currently hosted by the United States of America and also some European countries. We do work with, on the other aspects of the program with other global change research programs, but in the interest of time, I will move on. Let me give a few examples of the type of scientific research that the World Climate Research Program is contributing to. First subject is the subject of ozone depletion. If you recall, in the late 1960s and early 1970s, we discovered that some of the chemicals that we use for refrigeration are depleting the ozone in the upper part of the atmosphere, therefore resulting in large amounts of ultraviolet radiation reaching the Earth's surface, especially over the polar regions, which would be hazardous to human health. Since then, the research program has been collecting observations to understand if the concentration of these ozone depletion substances is changing because we replace the chlorofluorocarbons with some substitutes, and if indeed, by decreasing the concentration of these substances, do we see a recovery of the ozone? These basically figures are summary of roughly 25 years of research. We have great confidence now that clearly the decisions that were made in Montreal and London that to reduce these substances is having the positive impact of ozone recovery. So the red line is actual observations. The blue line is the model predictions or projections. The shaded area around each gray areas, it gives us this uncertainty with our ability to predict this. But the example that I'm giving here is that we have done this very successfully for the subject of ozone, and we can do this for the subject of climate, although climate is much more complex than the ozone. But there is tremendous confidence in the ability and in the science that we do here, and the policymakers really do now accept these model predictions or projections. And basically the major conclusion is that in about 50 years from now, the ozone concentration in the upper part of the atmosphere will be back to the levels that were in the 1960s, and therefore the exposure to the UV in the higher latitudes will be minimal. So one of the sort of many functions that the World Climate Research Program does is coordinating, collecting observations, putting them together, doing the quality check to create long-term records for researchers around the world. All the countries and programs that participate in this activity have free access to this observation. There is no restrictions. It's basically based on mutual cooperation, and they use these observations in their research to do experiments like this. For example, being able to do the energy budget or the radiation balance of the entire planetary system. Being able to say how much of the sun's energy that we receive is absorbed in the atmosphere, how much of it is available at the surface, or how much of it is absorbed by the ocean, and is the planet as a whole in a radiation balance or energy balance or not. Currently, the best we can do, the error associated with this knowledge is about 10 watts per square meter. We still are not perfect. The biggest component of it is the long wave radiation. We cannot quite measure it precisely, account for all of it clearly, but this is a subject of research at the planetary level. This is an example of the type of research that the World Climate Program is facilitating. Another example is a focus on sea level variability and change. Dr. Al-Mazrui mentioned this, and this has been the focus of the program for the past 20 years, trying to understand how the sea level will change as a function of time. And two major focuses, the global level and regional level. What are the components that contribute to the sea level variability and change? They've gone back in history and reconstructed some of the sea level based on the paleoclimate